Pinewood Derby cars have something in common with NASCAR and Formula One race cars: solid lubricants. Hi, I'm Lake, the motor oil geek, and while everyone knows that oil is a lubricant, not every lubricant is an oil. That's right. The graphite powder used to make Pinewood Derby cars roll faster has a cousin that's used in aerospace and motorsports. So let's go visit my good friend, Dr. Peter Lee at Southwest Research Institute to dig into the tribology of solid lubricants. When we removed the oil, the friction dropped. We didn't expect that. So Peter, why use graphite to make your Pinewood Derby car go faster?
Well, you've got interacting surfaces again, Lake.
Yep.
So this is tribology. You've got two surfaces moving over one another, one stationary, and the axle, which is turning, is rotating. And you want something in there to reduce the friction. Now, the Pinewood Derby, like motor racing, has got rules. And the rules say that there's certain things you can't do. Doesn't say you can't put that in. And that, which is basically carbon, which is very, very smooth and low friction, gets in between the surfaces and allows it to be low friction.
The only downside of this is you got to keep putting it back on because it wears off.
Yes, so there are options out there. Think about carbon. That's all it is.
Right.
Diamond-like carbon is a solid surface that you can put down.
Yeah.
And that stays place.
Yeah.
Now, think of an extreme situation for that. If you put that carbon on, say, a hinge in space, it's just going to disappear. So if you have something that's DLC, like this, which is a tappet out of an engine, and you DLC coat it, it's there. It's permanently there.
Not going to go
It's not going to go anywhere.
Right.
So that's why we have solid film coatings.
So the DLC basically gives you the advantage of the carbon
without having to put it back on all the time.
Yeah, it's kind of cool.
Yeah.
How can we quantify? Because again, this channel is all about the science, not speculation. How can we quantify the benefits of a solid lubricant like this?
I have an idea. Why don't we go back and use the block-on ring again?
Okay.
And let's do a steel block on the steel ring and then add that carbon in and see what happens to the friction.
That'd be cool.
Yeah.
Let's do that.
Okay, so here we are in the lab where we were before, and you can see the rig behind us that we're going to be using for this work. So here we have the ring, just to explain what we're doing, which is just a steel ring. And then we have a block that we're going to load on top of that ring, and we're going to rotate the ring and keep the block stationary. And that load we can increase over time to see how that affects the friction response. Okay, so here we can see the results of those friction curves, and this is two different tests that we've performed, and we'll go into that detail a bit later. But these two friction curves here show how the block and the ring have responded, interacting with each other over time. And what we're going to do is we're going to take the block, and here's an example of a block with a wear scar, and we're going to take that over to the white light interferometer, and we're going to measure that wear scar and actually give it a volumetric value so we can compare the two tests that we run.
Okay, grab it again, that way you can actually see that. Yeah, add some of that.
So dry lubricants are excellent, but if you try and get too clever with them and you put them in, say, an engine and you do a DLC on the DLC, you have to think about what your additive package is in the oil to make sure that they're all going to work nicely together, because your oil is a lubricant and your dry DLC is a lubricant. So they still need to work together. An example of that is here we have a camshaft that's been DLC coated on the tappets, and we saw this one just now. Well, what happens if you don't make it work properly is you end up with this looking like this.
So not all coatings are DLC. In fact, you guys here at Southwest Research have developed lots of different coatings. One of the most innovative ones is a variable hardness coating. Peter, explain what that is.
Okay, so the hard coating itself, it's on a steel base, so in this case a piston ring, and it's a very hard coating. And as we go towards the end of the process, we change the constituents of the gas that are in the chamber, and that makes the coating become softer. So for running in, that's perfect.
Well, because a DLC is like 2,400 Vickers hardness.
Yes, yes.
So it's really, really hard.
Yes.
But you can, with the variable hardness coating, make it around 600, 800.
Six to 800, and then on the start, and then it gets harder as you slowly wear through the process. So that, I mean, like I said, for running in, that's perfect because you want to run in gently and knock the asperities off carefully and have a nice smooth surface without ripping them out.
Right.
And then you get down to this nice running surface. You need something that's going to be hard, so it's durable, and also that's low on friction. And that's what the hard coating does.
See, it's perfect because we've been this before. The most amount of wear in an engine that's going to occur is during break-in. And you want to reduce that amount of wear because all that stuff does bad things because it doesn't go straight to your oil filter. And unfortunately, the oil filter doesn't take it all out. So if you can reduce the amount of asperities breaking off, moving around the engine and causing collateral damage, that's just better for engine life. So this is like having your cake and eat it too.
Oh, absolutely. Yes.
Less wear, and we've proven that before.
We have, yeah, we've shown that.
Along with better durability and lower friction. It's the best of everything.
So one of the things that we've done is we've actually run, instead of a steel block on a steel ring, we actually put in this test rig here a PTFE block on a steel ring. And we ran that, and what happens is the PTFE does wear a lot faster because it's soft, but it actually transfers across to the steel, so you end up running PTFE on PTFE. So the friction goes down. Just to show that, we also then took that PTFE block out and put a steel one in. So at this point we have a fresh steel block running on a steel ring that's got PTFE that's transferred onto it. And we ran that as well. And as you can see, the friction slowly comes back up to steel on steel values because that PTFE wears off with time.
The channel might be called the Motor Oil Geek, man, but Peter, I love Tribology more than I love motor oil, and these results probably show that.
Oh, they do. They show that. So when you look at the wear for the steel on steel, that was really high friction. That's what we expected.
Right, it's steel on steel, like you should not do that.
High friction, high wear. And then we do DLC on DLC, really low friction and really low wear. Added some oil in.
Right.
And it hardly changed the friction or the wear.
It was pretty crazy.
Yeah.
From my NASCAR background, we knew that if you reduce the amount of oil you were putting on things, when they were DLC coated, efficiency increased because you didn't have all the churning losses.
Yes, yes.
But I would have never guessed that if you just took the lubricant away completely, that the friction would drop like that.
Kind of makes sense, but it's still quite a surprise that it's that dramatic. In a real application, it's going to be cooling as well.
Right, absolutely. Yeah. Oil isn't just a lubricant. It also cleans, it cools, it transfers power. It's got lots of other jobs to do, which makes motor oil interesting because it has so many jobs to do. But in this case, if you're trying to reduce friction, you're trying to reduce wear, I mean, DLC is where it's at.
And going right back to the beginning when we said about space,
right.
Well, you don't need the lubricant, the DLC works.
Right, and because most lubricants will not exist in a vacuum.
Well, no, they'll just disappear.
Right, yeah.
Yeah.
Unless it's PFPEs, and then that's like, well, that brings up a good point. PFPE lubricants won't evaporate in a vacuum, and that fluorine in there also has a cousin, PTFE.
Yes, it does, PTFE, good point. So we ran those PTFE things, which we did that block on ring and we did the other.
And again, PTFE, super low friction as long as it's there.
As long as it's there, which in the block on ring test we saw disappear. So it wasn't there.
Warning, despite the misleading claims made by a couple of viral AI-generated videos, adding molybdenum disulfide, MOS2, to your motor oil doesn't make it permanently adhere to the metal surfaces or make your engine last forever. In fact, the opposite is true. High levels of molybdenum tend to lead to high levels of deposits. We're going to show that in an upcoming video. Also, as soon as new oil without the MOS2 is added to the engine, the detergents wash all the moly away, and high levels of molybdenum actually increase wear on DLC-coated engine parts. If all that wasn't enough for you, here's one more technical detail. Solid lubricants like molybdenum disulfide or tungsten disulfide are not fully soluble in oil. Think about sugar in iced tea. Because they're not fully soluble, they tend to fall out of suspension. So, putting solid lubricants in your oil isn't a good idea. See, every time we come here, we learn something new every time, whether we intend to or not.
Just move in.
I would love to do that. So it's pretty obvious that DLC is a pretty amazing coating. It has amazing tribological properties that can really help you solve problems.
Oh yes, we've solved numerous problems using DLC.
So if you want to see more non-oil related lubrication from the Motor Oil Geek channel, hit that subscribe button and let us know in the comments below, and we'll see you next time.